Section 3.2 starts on page 17, talks about measures of variation. Importance of variation. So variation is how far are you from what you want. Advil and Motrin IV produce the same headache relief medication with the active ingredient ibuprofen. So they both have the same medication. Each pill contains 200. It should contain 200 of the ibuprofen. A health agency obtains a sample of 10 tablets from both manufacturers and measures how much ibuprofen is in each pill. They go with Advil. Remember, it's supposed to be around 200 milligrams. Advil has in the first 199.25, so 0.75 below, 1.5 milligrams below, 0.10 above, 0.75 above, 1 above, 2 below, 0.10 above, 1 below, 1.10 above, and 2.2 above. You can't get it exactly 200. It has to be a bit more, a bit less. Motrin, on the other hand, 5 above, 4.2 below, 5.2 above, 3.2 above, 5.8 above, 5.6 below the 200, 4.6 milligrams above what it's supposed to be, 3.4, 7.2, and 3.8. Both of those are acceptable ranges, but each sample has a mean of 200 milligrams. However, based on the given sample, which company would you prefer to buy from? If it was me, I would prefer to buy from Advil. And the reason for that, preferred. Because the values are closer. Because the values are closer to 200 milligrams than of Motrin IV. Alright, here's another example. It says the following are temperature in degrees on 4 consecutive days in Mongolia in January, -3, -4, 2, and 6. Find the mean. The mean is -3 plus a -1 plus a 2 plus a 6 divided by 4, and that turns out to be 6, 8, 4 over 4, 1. Now they're asking how far away is each number from the mean. Remember, the mean is 1 right there. That's the mean. I should plug this more. So -3, that would be 4 below. -1 would be 2 below. 2 would be 1 above. And 6 will be 5 above. So, how far is each number from the mean? That's all they want. Now, if you add those, do you notice that you get a 0? Just a note. Measure of variation. So here you're trying to figure out, not kind of like what the middle is, kind of is, how far are each measurements from the middle? So that's how you do it. You have to figure out differences. It's not that simple. First, we start off with a definition of what a range is. The range of a data set is the difference between the largest and the smallest value. Very simple, straightforward, nothing to it. Standard deviation, this is something we're going to be using for some time, actually a long time. The standard deviation, denoted by S of a set of sample of values, is a measure of the variation of the values about the mean. It is a type of average variation of the values from the mean. So it's really a big deal for us. We have two formulas. We have this formula and this formula. This turns out to be a shortcut compared to this. We'll discuss why, and we'll do both and show you. But you could use either one. These formulas are provided in your test. You don't need to memorize them. Note, each form can be tricky, but the alternative formula tends to be easier. So they like this. They say it's easier than the other. Standard deviation of a population. So notice this is the sample size. And if we want the standard deviation of a population, we denote it by delta. Of a complete set of values is a measure of the variation of values above the mean. It is a type of average deviation of values from the mean. The same definition as before with one minor exception. This is population. That's the only difference. Now, which formula to use is up to you. I think I said it backwards. This formula is easier to use than that. But again, you're going to make your own decision and you proceed accordingly. So, there we go. Perfect. Okay. Let's look at the second page. There's a note. It is rare to compute a population standard deviation. It's very hard to do. And I'll tell you how they get around it. Therefore, when using technology, be sure to use the sample standard deviation unless otherwise noted. A population standard deviation is normally given to you. You don't find it yourself because they're not going to give you the entire population and say, here, do all of this calculations. But they have kept record of, say all the people that had skin cancer in the past 60 years, and they consider that to be the population, and they already have the standard deviation for that. So when they do a problem on that, they'll give you that value. Normally, if you're finding the standard deviation, you're always using the sample because you're accumulating a finite number of data. You're not going to get, 3 million data points and say, here, calculate the average. It's normally, 10, 15, something like that. So, the variance denoted by S squared for sample, delta squared for population of a set of values is the measure of variation equal to the square of the standard deviation. So here keep in mind, S is the standard deviation, S squared is the variance. These formulas tell us how to find the variance. You square root it and that gives you the standard deviation. So keep in mind how this works. First, find the range, find the standard deviation and the variance of the following sample of number of chips in 9 randomly sampled fun-size bags of Doritos. You know those small bags of Doritos? Fun size, they sell them at like Walmart, 2 for $1. They sampled 9 of these bags. So first, let's get the range out of the way. To find the range, you take the largest value. What's the largest value in this case? I'm looking. 32 seems to be the biggest. Minus the smallest. The smallest appears to be 19. So that would be 13 chips. That's the range. Now, they're going to have me use both formulas. They're having me set up everything for both formulas. Well, let's see. If I really want to use both formulas, first formula states s squared equal n times the sum of x squared minus the sum of x squared, all divided by n into n minus 1. And the standard deviation, of course, is the square root of that. So, second formula states s squared equals the sum of x minus x bar squared over n minus 1. And s is the square root of that. So to be able to do both of those, well, first things first. The sum of x quantity squared, these are the x's. I need this number. So I'll get my calculator and add all of those. And if I do that, I will get this number to be 234. I keep on forgetting to press this number. Here we go. N in this case is 9. That's 9 chips times n minus 1, which is 8. So far so good. Here, I could say this denominator is a 9. Now what I need to figure out what the average is to use this formula. Well, to find the average, I need to add up all of these and divide them by n. So since I added those right there, you know what, use the alternative form. Okay, I see. So here, we're going to use the alternative form down there. There we go. And we're going to use the traditional right here. So I need the average before I begin. Well, to get the average, let's go ahead and do 19 plus 20 plus 24 plus 25 plus 26 plus 28 plus 31 plus 32 all over 9. Or I could have just said that is 234 divided by 9. The average turns out to be 26. Now take 19 minus 26. That is a negative 7. Negative 7 squared is 49. Take 20 minus 26, that's a negative 6. Negative 6 squared is 36. Take 24 minus 26, which is a negative 2, square, you get a 4. Take 25 minus 26, that's a negative 1, square, you get a 1. Take 26 minus 26, that's a 0, square, you get a 0. 28 minus 26 is a 2, square, you get a 4. 29 minus 26 is a 3, square, you get a 9. 31 minus 26 is a 5, square, you get 25. And 32 minus 26 is a 6, square, you get a 36. Add all of those. And if I add all of this on my calculator, I'll get 164. This part is needed right there. That's how complex this is. So here I'll get s squared to equal 164 divided by 9 minus 1, 8. Right? That turns out to be 20.5, and S would be the square root of 20.5. So this is the variance. And if I square root this, I'll get 4.5. This would be the standard deviation. Now this and this mean both of those mean approximately. Oh boy. Both of those mean approximate. Okay, so this is the original. This is the alternative. To do the alternative, I need this value. And that's what we're going to do right here. We already know this is 234, but here, if we square those, if I square this, plug in a calculator, I'll get 361, square 20, I'll get 400, square 24, 526, 625, 626, 784, 841, 961, and 1024. And if I add all of those, I will get 6,248. And I want to really demonstrate really quick how to do that one shot. You really don't have to write this down unless I give you the table and you want to fill it in. But if you're just using the calculator, let me see if I could shrink it to fit. Okay, we could see it right there. So if I take 19 and I square it, the squared key is right there. Add to that 20 squared. So that's how you do it if you were doing it on your own. Now, later on, we're going to show you how to do that by a list and tables. That's in chapter 5. But for now, let's proceed and learn how to do this. 26, 28, 29, 31, and 32. And there it is. And that's how we do it. So this is 6,248 multiplied by n, which is 9. So if I plug this in my calculator, I'll get s squared. This will be 20.5. Again, I could show you how to do that really quick. You will take parentheses 9 times 6248, close parentheses. I'm sorry, no, there. Minus parentheses 234 squared, all of that divided by parentheses 9 times 8. There it is. And square root that. The square root key on your calculator is second right there. And if you go for the answer, there it is, 4.5 roughly, 2 decimals. So s equal the square root of 20.5, and that's why we say s is approximately, because we're approximating that. Standard deviation and variance. So if I was looking at, so now they're trying to figure out if you understand what this variance means, or standard deviation. It says, if you want to get a bag of chips every day you buy one bag of chips, would you prefer to have a small or a large standard deviation between the bags? I would rather small. Why is that? Because that would indicates the amount of chips in each bag would not vary would not vary much from bag to bag. That's what that means. So it's kind of like when you go and buy fries at McDonald's. If you buy it one day, each day, you should get about the same amount. You're never going to get exactly the same amount, but it should be very close. That's normally what we aim for. I'll finish this in the next video.